right, so in this video, we're going to go over equations. Okay, let me zoom in just a little bit. I'm gonna make this slightly bigger, see if it's easier to read when it's rendered. Okay, so in this video, we're going to do a little bit of evaluating algebraic expressions. First, when we evaluate, we're saying if x is 3. Okay, I don't know if x is 3, but if it is 3, what would that make the output? What would that make the answer? Okay, and this is it's very important for you to realize that it's only this when x is 3. Because if I say x equals 5, x equals 4, x equals 6, the answer is going to change. The output's going to change. So we have to tell the next person the same thing. Okay, so what I do is I take 3 and I'm going to substitute it in for x. All right, and I'm going to go 2 times 3 is 6 because the order of operations says I do the multiplication first. Then I'm going to add it's 11. So when guess I didn't have to put so. X equals 11, the output or the answer, however you like to put it, will be 11. Okay? Only when x is 3. And that is the beginning step of functions, is being able to get that idea. Give me some more room. All right, in this one where I see an x, I'm going to put a 7 in. It's very important that I keep this in parentheses just in case it means multiplication, which it does happen to mean that in this particular case. All right, so when I take 5 times 7, I get 35. And if I minus that 10, I get 25. So when x equals 7, the output will be 25. So only when x is 7 will it be 25. If I say x is 2, we got a completely different output. All right. So in class, we talked about the opposite operation. So I'm just going to run down through and write our opposite operations here. And this is going to kind of be our reference sheet as we go along of what I do in these situations. What is the opposite operations going to be? Remember, I also talked about with equations, we have this thing of an equal sign. This means I'm going to be equal to both sides. So if I have a quarter over here and 2 dimes and a nickel over here, if I take a nickel away from this side, they're no longer equal. 25 does not equal 20 cents. So I have to break this thing up and say I make it into 4 nickels. Now that is equal to my 2 dimes. All right, so if I take 5 away from one side, I got to take 5 away from the other side. That is the rule of equality in math. It has to do with any times you have an equal sign. So it's saying that even though this 25 does not look the same as my 2 dimes and a nickel, the values are the same. What they represent is the same. Same thing here in example 35. X plus 3 does not look the same as 12, but what they represent, the value that they represent is the same. Okay? All right, so I have to solve for x. So the way I do this is by using opposite operation. An opposite operation actually undoes PEMDAS. Okay? So where PEMDAS I did addition and subtraction last, it's after parentheses. Parentheses always go first because it means do me first. I have to resolve the do me first before I get into the rest, okay? So addition and subtraction, then multiplication and division, then exponents and radicals. And I'm being selfish. I'm looking from the point of view of the x. This is very important because you're going to get the wrong opposite operation if you look at it from the 5's point of view or the 12's point of view. We have to look at from the x because the x is what I'm trying to get by itself. Okay, so if I look at it from the x point of view, the 5 is adding the x. Okay, the 5 is adding to the x. Well, opposite operation says to undo it, I have to subtract. Let's see what happens. What's plus 5 minus 5? Well, it's 0. The identity property of multiplication tells me if I add or subtract a 0 to anything, it doesn't change it. So this isn't going to change the fact that the answer on this side is x. Now, I just told you the rule of equality. If I'm going to subtract 5 from a side, I have to subtract it from the other side. So make sure that what you do, the opposite operation that you do, is what you do to the other side. I don't want to add 5. I want to subtract, because subtracting is what I added to the equation. It's what I decided was important, was the way to undo that plus 5. So whatever you do to the side, not whatever's already done, but whatever you do is what you have to do to the other side. All right, so 12 minus 5 is 7. So I know that x equals 7. Let's say I want to check myself. All I have to do is evaluate it for when x equals 7. That means putting 7 in for x and evaluating. 7 plus 5 is 12, and 12 does equal 12. It's a true statement. It checks. All right, so in this one, the 12 is being added to the x. So the opposite operation to undo it would be to subtract it. What I do to one side, I must do to the other. So I'm also going to subtract a 12 over here. Well, plus 12 minus 12 equals 0, only leaving me with x. 29 minus 12 is going to give me a 17. Okay, so x equals 17. Let's check that real quick. And it checks. Awesome. All right, let's go on to the next one. All right, in this one, the 15 is being subtracted to the x. So to undo it, I must add it. So the beauty in this, and what I do to one side, I must do to the other. The beauty in this is that negative 15 plus 15, if I owe $15, but I have $15 in my pocket, that means I break even, they go to 0. They cancel each other out still, and all I'm left with is x. 32 plus 15 is going to give me 47. All right, in this one I have the same thing going on. The 2 is subtracting the x, and so to undo it, I have to add it to both sides. That way I get that identity property of this going to 0, leaving me just with x. 19 plus 2 is going to give me 21. All right, now I have a different operation. I have no adding and subtracting, so I go to the next thing, and that is multiplication and division. In this one, the 2 is multiplying the x. So to undo it, I have to divide. What I do to one side, I gotta do to that other side. 2 over 2 is 1. 1 times anything. That's the identity rule of multiplication. Doesn't change anything. I'm still left with an x. 2 goes into 10 5 times. All right, again, I have multiplication. So to get rid of that 5, I got to divide it on both sides, leaving me just with x, and 5 goes into 25 5 times. Now, I could check that by just substituting 5 into the equation. 5 times 5 is 25. I already found the answer was 25. It checks. All right, in this one, the 5 is dividing the x. So the opposite operation is actually to multiply it. And you got to do that to both sides. That means these are going to cancel, leaving me just with x. And 2 times 5 is 10. Now let's go ahead and check that one too. I'm going to fill in 10 into the spot of my x. 5 goes into 10 2 times. 2 equals 2, which checks out. All right, in this one, the 3 is dividing the x. So to undo it, I have to multiply it on both sides. A negative and a positive 3 is going to give me a negative answer of 36, and all I have left over here is an x. All right, so what if it's written and the variable is not the first thing I see? In this example, see, the x is second. Okay, it's hard to tell what that 5 is doing to the x. Sometimes people will tell me it's subtracting. It's not the 5 subtracting the x. It's the x subtracting the 5. So I'm going to flip-flop it. You can flip-flop whatever you want in equations as long as it stays on the same side and it remains its same sign. So in other words, this 5 is positive, this x is negative. When I flip-flop them, the x better still be negative and the 5 better still be positive. So look here, I just flip-flop them. All right, now I can clearly see that that 5 is adding to the x. So to get rid of it, I've got to subtract 5 from both sides of my equation. Oh, now I got a negative x. What do I do? Well, there are two ways you can look at this. First, you can look at it like there is a understood 1 there. So it's actually a negative 1x. Remember I said that we don't write that. Math people do not want to write their ones in because it's redundant. I can clearly see there's 1x there. Why do I have to write 1? But if you write it, it's not a big deal. I don't even mind at all, okay? All right, so now I can see that there's a negative 1 multiplying to the x, so to get rid of it, I divide it. 1 goes into 5 times, a positive and a negative makes a negative. Another way that you could look at it is that no matter what, if I have a negative x, I can just reverse the signs of everything. Make the x a positive, make the 5 a negative. Just take the opposite sign of everything. Some people like to look at their negatives as reverse the sign. Okay, if you want to do it that way, you can. Neither way is necessarily wrong. It's just about the way that you view the content. All right, so again, what I'm going to do is kind of flip-flop these terms. The x has to remain positive, and the 10 has to remain negative when I flip-flop it. If you decided to write it like this, there is nothing wrong. The 10 is still negative, and the x is still positive. So it doesn't matter which way you draw it, you write it. Okay? All right, so to get rid of that 10, I'm going to add it to both sides. That's going to give me 0 here, leaving me just my x. A negative 2. I owe $2, but I have 10 in my pocket. I'm going to have 8 in my pocket. All right. Now we're going to get into some serious multi-step equations. Let me see if I can fix this. What's going on here? Okay. So now we're going to do some two-step equations, and then we're going to add some more steps, and we're going to be equation-loving geniuses when we're done. Okay, so remember the first thing I'm looking for is adding and subtracting. I have an adding right here. The 9 is being added to the x, okay? The 2 is being multiplied to the x. So I have a 9 being added, a 2 being multiplied, so I know I'm going to subtract and divide to solve this. Okay, so plus 9 minus 9 equals 10. Got to do it to the other side. Got to be fair and equal. So I have 2x equals 1. Okay? See if I can change the thickness of this. It's a little markerish. All right, the 2 is being multiplied, so I'm going to divide. There is nothing wrong with keeping your answer as a fraction. But if you decided you wanted to write it as a decimal, you can. All right? So it's 1/2 because this is going to cancel, and I don't have to solve that if I don't want to. If I want to, I can, though. All right. In this one, the 6 is subtracting the x, and the 3 is multiplying to the x. So I know I'm going to add and I'm going to divide. All right, so first I do my adding and subtracting, so I'm going to add 6 to both sides of this equation. All right, and then the 3 is multiplying, so I'm going to divide 3 from both sides, giving me x equals 6. And if I want, let's just throw that back in, put 6 in for x and see what happens. 3 times 6 is 18. 18 minus 6 is 12. And that's true. It does equal 12. It checks. All right. In this one, the 2 is adding to the x. So the first step is I need to subtract 2 from both sides of the equation. Next step is the -9 is multiplying the x. Very, very important that I take the whole thing, sign and all, because if I don't, I'm going to be left with a negative sign that I have to get rid of later. I'm going to have another step. Okay, so I'm going to divide both sides by the -9. See, two negatives are going to make a positive. It's going to be a positive 1, which doesn't mean anything. If you want to write 1x, it's not the end of the world, you can. 9 goes into 18 2 times, and it's going to be negative because I have a positive and a negative number. All right, let's go ahead and check that one. All right, so a negative and a negative make a positive. 2 times 9 is 18. 18 plus 2 is 20. 20 does equal 20. I wanted to see how many. We have 70. I think we could do it all in one video. Let's see. All right. In this one, I need to add 10 to both sides because the 10 is subtracting the x. These cancel. 14 plus 10 is 24. The -6 is multiplying the x, so I'm going to divide -6 on both sides, giving me x equals 4, and it's going to be negative because I have positive and a negative. All right, what do we do when there's a fraction? Well, the first thing I can see that I have to do is add 2 to both sides of the equation. Okay, it's going to leave me with 1/2 x equals 15. All right, so the 2 is being multiplied. The 1/2 is being multiplied to the x. So to undo it, I have to divide 1/2 from both sides. And I'm just going to walk this through every single step. Might quicken up on the next one, but for this first one, let's walk through every single step. So to divide fractions, I do keep, change, flip. I keep the first fraction, I change division to multiplication, and I flip the second one. This is going to become 2 over 2, which equals 1. It cancels out, just leaving me with x. Over here, I have to do the same thing. I got to throw a 1 underneath my 15, turn it to multiplication, flip the second one, and I find that that answer is 30 over 1, or just plain 30. So x equals 30. All right. So the first thing I see is I need to subtract 6 from both sides. Let's go ahead and get rid of that. Don't want to deal with it with my fraction. So I have 3/4 x equals 6. Okay, I'm going to skip right to keep, change, flip. So keep the first fraction, change the multiplication, flip, do that on the second side as well. Okay, and I'm just going to cancel right here. This 3 is going to cancel with this 3, this 4 is going to cancel with this 4, leaving me just with x. On the other side, I'm going to have 24 over 3, which 3 goes into 24 8 times. Let's go ahead and check that one. All right, so I'm going to make this fraction so I can multiply. On the top, I'm going to have 24. The bottom, I'm going to have 4. 4 goes into 24 6 times. 6 plus 6 is 12, so it checks. All right, so let's combine some like terms now. Sometimes we have a big old mess that we have to clean up before we get started with our math. So I only want to combine like terms that are on the same side of the equation and then use opposite operation to clean up the rest, okay? So 250 plus 350 is going to be 600. Over here, I have some understood ones. If I combine those, I have 2m minus 12, okay? I'm just going to flip-flop the sides. So it doesn't matter, that's a preference thing. I'm just going to bring this whole side over there and this whole side over there. It doesn't change the answer whatsoever. I can see that this 12 is being subtracted, so I'm going to add it to both sides of my equation. And now I'm going to divide it 2. And the answer is 306. All right, let's do the next one. My questions are disappearing. All right, let's just go down and do it this way. Don't want my questions to disappear. All right, so on this side, I can get these two combined. So a negative 3r minus a 5r is going to be a negative 8r. It's like if I owed $3 and I owed $5, I owe $8 in total. Now I want to bring this whole thing to the other side. Well, I know a tool that will help me get rid of something on the other side, but I got to make it turn into a 0. So 2r is only going to turn to a 0 if I subtract 2r. 2r minus 2r is 0. Okay? What I do to one side, I've got to do to the other. So I'm also going to subtract a 2r over here. It's going to give me a 10r. Like I said, this is going to turn into 0, leaving me with a 4. Now, like I've said, I don't like the way this is written. I want to flip-flop. So I'm going to make it negative 10r minus 16. See, they keep their signs. Equals 4. Now to get rid of that 16, I'm going to add it to both sides of my equation. It goes away right here. Next step is I have to divide that negative 10. R equals, it's going to be negative, and 10 goes into 22 times. All right. Ah! Huh. Oh no. Yeah, I don't know what's going on. Okay, so I'm going to stop there at example 52 and try to figure out what's going on, and then I will make another video.